Welcome to the Falcon Tactical Edge demo powered by AccuKnox CNAPP for runtime defense against tampering of model weights and AI spoofing attacks. We have our Lava multimodal AI model deployed and running on KServe. Our goal is to perform a quick safety check on this image of a construction worker. Next, we'll craft a specific prompt, asking the model to analyze the image and identify the worker's headwear, expecting a simple hard hat or soft hat response. We send this prompt and the image to our model's API endpoint with a simple curl command, and instantly we get our result. The model correctly identifies that the worker is wearing a hard hat, demonstrating a powerful use case for automated safety compliance. Our Lava model runs on KServe, pulling its data directly from a Minio storage bucket. As we've seen, it works perfectly, but this creates a critical dependency. What happens if our storage backend itself is compromised? Let's assume Minio has a remote code execution vulnerability. To simulate an attacker exploiting this, we'll use kubectl exec to get a shell inside the Minio pod. We can see the model files are located right here in the data directory. Since the attacker now has write access, they can replace the original model with a poisoned one. This poisoned model has had its output layer weights randomized. For this demo, we'll use kubectl to perform the malicious swap. The next time the inference engine starts, it will unknowingly pull the poisoned model from Minio. Now, let's hit the service with the same prompt and image we used before, and the result is complete gibberish. The model is useless, and the supply chain attack was a success. In this image, the AI model correctly identifies that the man is holding a gun. But imagine if this model were poisoned. It could misclassify or ignore such critical details entirely. This kind of model compromise could undermine public safety systems, render surveillance ineffective, and pose serious risks in high-stakes military environments. Let's see a different scenario. The AI model detects that a woman is stealing goods from a store. Now imagine if the model were poisoned, it could fail to flag thefts, making surveillance and automated monitoring useless. In high-security or defense scenarios, such manipulation could lead to devastating breaches and loss of control. So how do we prevent this? We'll use KubeArmor to enforce a zero-trust policy. This policy dictates that only the legitimate Minio binary is allowed to execute in the pod, and more importantly, that the sensitive /data directory can only be accessed by that Minio binary. Let's apply the policy and try the exact same attack again. We try to get a shell, and we're blocked. Access is denied at the source. The model is now protected from tampering. Voila! The attack is prevented, ensuring the integrity of our AI model supply chain with runtime security.